Dear students, in today's session, we are going to discuss phase diagram of lead-silver system. Before going to phase diagram of lead-silver system, we will understand what is eutectic system. Eutectic means easy to melt. A binary system in which two components are miscible in all proportion in the liquid state, but they do not chemically react, and due to mixing, they shows the property of lowering of each other's freezing point. Such a binary system are termed as eutectic system. Eutectic mixture. What is eutectic mixture? A solid solution of two component system which has the lowest freezing point of all the possible mixtures of all the components in all eutectic is called as eutectic mixture. That means the eutectic mixture is the mixture of fixed composition corresponding to lowest melting point or freezing point. So what are the properties of eutectic mixture? Eutectic mixture has a definite composition and sharp melting point. Thus it resembles to a compound. If we observe the physical properties such as density and heat of solution of eutectic solid, they are almost equal to the mean values of the constituent. These are not compound as the components present in eutectic mixtures are not in stoichiometric proportions. But these eutectic mixtures have a different application. The alloys which behaves like a eutectic mixture are used as fail-safe devices in boilers, in fire sprinklers, and in other safety devices. They can be used as plugs in automobiles. Eutectic systems, because of their low melting points, are also used for joining two metal pieces together. Now, in general, when we give phase rule, it is F equals to C minus P plus 2. These here, the number 2 represent two variable pressure and temperature. But in metallurgical system, as the pressure is kept constant, the contribution of pressure is nullified, and hence the phase rule gets modified as F equals to C minus P plus 1, and this is known as reduced phase rule. F equals to C minus P plus 1 is termed as reduced phase rule. Now here we come towards the phase diagram of lead-silver system. In metallurgical system, as the pressure is kept constant, hence the phase diagram is plotted between temperature on x-axis and temperature on y-axis and composition on x-axis. Here, as observed in earlier phase diagram, there are different regions, different curves and points. So in lead-silver system, there are 4 different possible phases present. Those are solid silver phase, solid lead phase, solution of silver and lead, and solid silver plus lead. These are the 4 different phases present in the lead-silver system. When two metals mix with each other, they do not react. There is no chemical interaction between them, and there is no effect of pressure on such a system. Hence, the phase diagram is plotted between the temperature on y-axis and percentage composition on x-axis. So in phase diagram of lead-silver system, there are different curves, curve AO and curve OB, eutectic point O, and there are different areas, area above AOB, area below AO, area below BO, and the dashed line here, shows the eutectic temperature, hence this line is known as the eutectic line. So there is another area below this eutectic line. Now first we will discuss the curve. The curve AO starts from 961 degrees Celsius, which is the melting point of silver, and as we move towards the point O, there is an addition of Pb. Because of the addition of Pb, there is a decrease in the freezing point of silver, and hence the curve AO is termed as the freezing curve of silver. Similarly, the curve BO starts from the melting point of pure Pb, that is 327 degrees Celsius, and again it goes on decreasing due to the addition of silver, and it reaches to point O. The curve BO is also termed as freezing point curve of lead. Along both these curves, there are two phases which are in equilibrium. Along the curve AO, the two phases which are in equilibrium are solid silver and solution of lead in silver. Whereas along curve BO, the two phases which are in equilibrium are solid Pb and the solution of silver in Pb. So hence the phase diagram, when we put the value of C 2, as it is a two component system, and P equals to 2, the value of F, degrees of freedom, comes out to be 1, and hence these curves represent univariate system. There is a point O which is known as the eutectic point. This eutectic point corresponds to a fixed composition of 97.4% lead and 2.6% silver, and this composition is known as the eutectic composition. The curve AO and BO meet at the point O, and this point is termed as the eutectic point. At point O, the three different phases are in equilibrium, that is solid Ag, solid Pb, and the solution of silver and lead. These three phases are equilibrium at point O, which is known as the eutectic point, and hence the value of degrees of freedom comes out to be 0. That means the point O represents non-variant system. The point O corresponds to 303 degrees Celsius, which is known as the eutectic temperature, as it corresponds to a fixed composition of 97.4% of Pb and 2.6% of silver, which is a eutectic composition. Now there are different areas: the area below AO, the area below BO, and the area below eutectic temperature line. All these areas represent two phases, and hence the degrees of freedom for all these areas will be 1. That means all these areas are univariant in nature. Now next is the application of phase diagram of lead silver system. The principles studied in the phase diagram of lead silver system can be applied for the extraction of silver from argentiferous lead. The ore of argentiferous lead contains originally very small amount of silver, that is only 0.1%, and 99% of lead. If we extract silver from this ore, it will be very costly, and hence we will carry out the enrichment of silver in argentiferous lead by using the principle used in the lead silver system. So what we do, we first melt the ore at 327 degrees Celsius, and then that ore is allowed to cool down. As the ore is allowed to cool down, there will be separation of Pb, separation of lead, with the decrease in temperature, and this separation will be carried out along the curve BO, and with the cooling the liquid starts to solidify and it reaches to point O with a constant composition of 2.6% of silver and 97.5% of lead. Thus we have carried out the enrichment of silver from 0.1% to 2.6%, and now the extraction of silver from this enriched ore will be very much economical. So it is all about the lead silver system. Thank you.